Hello everyone, welcome to ETSI MEC Forum. My name is Alice Lee. In this session, I'll provide you with update on ETSI MEC standards. Currently, I am the Vice Chair of ETSI ISG MEC. This is my short CV. MEC Multi-Access Edge Computing is one of the ETSI ISGs. Our mission is to enable cloud computing at the edge of the network through standardization. So far, there are 120 members in ETSI MEC, including operators, technology vendors, IT players, and application developers. Together, we have created the foundation for edge computing. For standardization-related activities, ETSI MEC has been working very closely with other ETSI ISGs and also other SDOs. In addition to the published standards, ETSI MEC also published several white papers on different topics. These white papers can be found on ETSI MEC homepage. We also maintain a MEC wiki page where you can find more information on MEC sandbox, hackathons, deployment trials, and POCs. Let me give you a recap on what we have done in ETSI MEC since 2015, when the ISG was founded. Phase 1 work started from 2015, finished about 2018. During this phase, we have published overall specifications, management APIs, service exposure related APIs. We also completed studies, one on MEC in NFV, another one on mobility support. To continue the work in phase 1, phase 2 work started from 2018. During this phase, we have published application mobility related API. To address key industry segments, we published V2X related APIs. The IoT related APIs is still ongoing. To address the key use cases and new requirements, we also published report on network slicing, report on container support. In addition to the radio network information service API, which was published in phase 1, in phase 2, we also published API specifications on Wi-Fi and API specification on fixed access. MEC integration in 5G networks is one of the highlights in phase 2, for which we have published a group report. Since 2021, this year, we have started phase 3 work. While completing outstanding phase 2 work, we have put lots of effort on inter-MEC system and MEC cloud system coordination. There are also several studies ongoing, including MEC in resource-constrained devices, MEC deployment in enterprise scenarios. To continue our effort on enabling and engaging developers, we're working on application package format and descriptor, sandbox development, testing, and compliance-related aspect. In this session, I'll provide you more information on two key topics. One is the MEC integration in 5G networks. Another one is on the inter-MEC system coordination. The integration of ETSI MEC with 5G system has created a larger tech world. 3GPP standardization work on 5G system and its support for edge computing has opened up opportunities for MEC. To investigate these opportunities, ETSI MEC started the study in phase 2 on MEC integration in 5G networks. The scope of the study includes control plane interactions with 5G core network, functional split between MEC and 5G core network, organization of MEC as an application function, as well as the interactions between MEC and radio access network. A typical 5G system is illustrated on the left hand. The MEC system is on the right hand. UPF, a user plan function, is a logical function connects to MEC system via N6 interface. In this study, first of all, we investigated the selection and relocation of UPF. In this case, MEC acting as an application function can request the 5GC to select a local UPF near the target RAN node. Use a local UPF for PDU sessions of the target UEs. Control the traffic forwarding from the UPF. The uplink traffic matching with the traffic filters is diverted towards MEC hosts. Other traffic will be sent to the central cloud directly. In case of UE mobility, the 5GC can reselect a new local UPF that is more suitable to handle application traffic identified by MEC, and also notify the application function about the new serving UPF. We also investigated the AF influence on traffic routing. In this case, MEC, also acting as an application function, can provide the following information to 5GC. Traffic filters, identifying MEC applications deployed locally on MEC hosts in Edge Cloud, the target UEs, as well as the information about forwarding the identified traffic further. Mobility event notifications were also investigated. 5GC allows MEC as an application function to subscribe to UE mobility events that may affect traffic forwarding to MEC applications, to receive notifications for UE mobility events affecting MEC application instances. To enable the alignment between 3GPP, SA6 EDGEAPP, and ETSI MEC architecture, a joint white paper has been published. The authors include both ETSI and 3PP officials. The harmonized architecture, as what you can see in this slide, has been recommended in this white paper. As a result, this harmonized architecture has also been captured in the informative annex of 3GPP TS 23558. There are ongoing efforts in both 3GPP and ETSI MEC to address the further alignment. Now I would like to focus on MEC Federation. MEC Federation is a federated model of MEC systems enabling shared usage of MEC services and applications. The related work in ETSI MEC was triggered by industry requirements from GSMA, especially with the publication of GSMA white paper in October 2020 on Tackle Edge Cloud, Edge Service Description and Commercial Principles. 8 months later, in June 2021, ETSI MEC published a very first work on MEC Federation in GR MEC 35. The existing MEC standards can already support intra-MEC system coordination. The coordination between MEC systems and between a MEC system and a cloud were within the scope of the completed MEC 35 study. Right now, we're working on the normative work in line with GSMA OP requirements. MEC Federation scenario of V2X services has been studied in order to identify the requirements for MEC system. This scenario is inspired by 5G AA use cases, including multiple MNOs, multiple OEMs, and multiple MEC systems. The identified requirements for MEC system MEC Federation include MEC system discovery, MEC platform discovery, and MEC platform level information exchange. There are three types of use cases with regards to multi-operator agreements enabling MEC Federation for V2X services. Type 1 use case is similar to national roaming. In this case, customers of operator A could access the edge infrastructure of operator B to ensure the best possible services. In type 2 use case, an application developer has a commercial relationship with operator A. Federation agreements could allow the application developer to deploy its applications in operator B's MEC system. Federation broker is a key feature in type 3 use case. A federation broker has a set of agreements with several MNOs. The MEC Federation scenario for immersive AR game has also been studied. A location-based immersive AR game is considered, which is designed to be played by all players at a specific geo area. The multiplayer interactive AR game can be supported only when the users joining the game are connected to the same MNO. Users of different MNOs cannot join the multiplayer interactive AR game, even when they are located nearby. There are two options to address the issue identified. In option 1, the AR game MEC Application X instances coordinate for real-time synchronization. The identified requirements for MEC include to enable a MEC application instance to discover another MEC application instance in the same or different MEC system, to support the onboarding and instantiation of a MEC application in a MEC system in response to a request with a key performance indicator by another MEC system. In option 2, the platform B redirects user force traffic to MEC platform A, as illustrated in the figure. Requirements for MEC to support the MEC application selection in an MNO's MEC system for a group of clans, to support a suitable rule for the efficient handling of the traffic between the MEC application hosted in an MNO's MEC system and another MNO's access network where the UE is connected. Having completed the study on MEC Federation, we have started a normative work on the related aspect. First of all, we have captured all the MEC Federation related use cases and the associated requirements in GS MEC 002. We're now working on the MEC system reference architecture variant for MEC Federation. In this architecture variant, a new logical entity has been introduced, MEC Federator. It enables MEC Federation between MEC systems. MEC Federator may support the following functionality: registration of MEC system information via MEO, MEC system discovery, broker capabilities, MEC system information exchange, application lifecycle management across different MEC systems, application monitoring across different MEC systems. There are exciting activities ongoing in ETSI MEC. Watch this space. In this session, I have updated you with the current status of ETSI MEC standards. In addition, I want to point it out, there are quite a lot MEC deployments in real networks across the globe. For more information, please take a look at the GSMA report. The link is provided on this slide. Thank you very much for your attention.